Yeah, hello, hello, hello. I hope I am audible now. Just done. Alright, I'm audible. Okay. Today we'll be starting with the second part of solutions. I will give you a brief summary of what we have done in the previous class. Then we'll begin with the new part that we'll be studying today. Mostly we'll cover about the equivalent mass and normality. That is the most important part of today's lecture. So first let us revise what we have studied in the previous class. Then we will begin with today's part. Okay. So in the last class we have studied about the basic idea of what is a solution. If it is a binary solution, it will have two components, solute and solvent. Solute will be the B part. I will represent with B and solvent will be A. Okay. Next. Types of solution. This is just for your memorization. It will not be asked in the exam. Next, I have told you this is the basic idea of how to calculate number of moles. Number of moles you can calculate by either dividing the weight of the substance, given weight of the substance divided by its molar mass, or by the volume by 22.4 liter, or number of molecules or atoms divided by the Avogadro number. Avogadro number is 6.022 into 10 to the power 23. Okay. This one also have told STP is 273 Kelvin, 1 atm, volume 22.4 liter. NTP is 273 Kelvin, pressure 1 bar, volume 22.7 liter. Sometimes it will be coming 298 as well. Okay, 298 Kelvin if it is mentioned, and you will use 298 Kelvin, otherwise you have to use these values. Though most of the time 298 Kelvin is given in the question, and in physical chemistry the standard value is 298 Kelvin. Okay. Concentration terms. Number one, molarity. Molarity, I have told you that molarity is going to vary with temperature. Why? Because molarity depends on volume, and volume changes with temperature. So it is going to vary with temperature, right? What is molarity? Number of moles of solute dissolved in 1 liter of solution is called molarity, right? Molarity is equals to number of moles of solute dissolved in volume of liter. So V volume of solution. Done. So M can I write it as NB into 1000 divided by V ml. Okay. Next, molarity will be, if I am expanding the NB, then I am getting WB by MB and 1000 divided by volume. So this all I have discussed in the last class. I am just giving a summary of that. Okay. I am just giving a summary of that. Next. Formality and molarity, they are same thing. No changes are there in formality and molarity. Only change is that instead of molecular mass we write it, or molar mass we write it as formula mass. Why? Because in ionic compounds it is arranged in a specific fashion called lattice. So due to the specific fashion or lattice, it will be called as formula mass, because there we cannot tell the molar mass like that, because it exists in a specific fashion. So same formula as molarity, only changes just in place of molar mass we will write with formula mass. This also varies with temperature. Why? Because again it is dependent on volume. All volume dependent concentration terms varies with temperature. Next we have to talk about molality. Molality is basically number of moles of solute dissolved in 1 kilogram of solvent. Previously we have seen it is volume. This is not volume, this is mass. So the formula of molality is molality and molarity. Two are different things. NB by WA. What is WA I have written? That means weight of the solvent, not the solution. The common mistake that is done is weight of the solution you all will take, but that is not the case. We will not take the weight of the solution. We will take the weight of the solvent only. So NB divided by WA in kg. Now in kg nothing will be given in the question, so you have to convert the kilogram into gram, because here it will be given in the gram. So into 1000 in the numerator, right? Kilogram to gram. Gram to kilogram is, you can divide by 1000, so it will be into 1000 in the numerator. Simple. So if I am expanding the NB again, then I am getting M equals to WB by MP into 1000 divided by WA. The derivation done. This molality is independent of temperature. I did not mention that last day. Independent of temperature. Why it is independent of temperature? Because there is no volume in this part. Mass will not change with temperature. So independent of temperature. Independent of temperature. Right? So even if I increase the temperature, the molality will not change, but molarity will definitely change. Okay, the small things to make a note of. Next, we have learned about the relation between molarity and molality. For that, we need the density of the solution. Okay, so if I have to find out molarity with given molality and density, then I will use the formula MD by 1 plus MMB by 1000. Small m is molality, D is density of the solution, capital M B is the molar mass of the solute. Okay, this is molarity you are finding out from molality and density. Now you can modify this formula to find M also. If you do not want to do that, you can just remember the second formula is 1000 M divided by 1000 D minus MMB. If you don't want to remember, it's fine because it's coming from the first formula only. So the formula you need to remember is molarity equals to MD by 1 plus MMB by 1000. This is the relation between molarity and molality. Next, mole fraction. Mole fraction we have learned the ratio of number of moles of a component, the component we are talking about, that component to the total number of moles in the solution. If we are talking about the component solute, then it will be the number of moles of solute divided by total number of moles. If I am talking about the component of solvent, it will be number of moles of solvent divided by total number of moles. So it is psi A, this is called psi. Okay, so psi A equal to Na by Na plus Nb and psi B equal to Nb by Na plus Nb. So since it is a fraction, then if you add these two fractions, you will definitely get 1. This is a very common observation, right? From here, if I am going to divide chi A and chi B, then I will get Na by Nb. That also you have to remember. So if I am taking the ratio of the mole fraction of two components of a solution, I will be getting it equal to their number of moles in the solution. Very, very important because this will be needed in deriving the next two equations, relation between molarity and mole fraction. Okay, next topic we have learned relation between psi and molality. And next one I have given you homework, that was relation mole fraction molarity. I hope you have done in the same way. I will not do, it was your duty to do. Okay, so M equals to NB by WA into 1000. So what we have done, we have just multiplied and divided by MA. MA was the molar mass of the solvent, right? So WA by MA basically became the number of moles of the solvent, and NB by Na became the, again it became the mole fraction. So that's how the mole fraction is to molality. Similarly, molarity also will find the same relation there. Okay, clear? In case of molarity, the volume part is there, mass part is not there. So you have to multiply both the mass part. Okay, then volume will remain there. So you have to multiply the mass part as well. That is the main thing. Okay, so this was your homework. You will try it in your home only. Okay, then we have discussed certain questions. I hope the questions you all don't have any doubt. We cannot discuss the questions anymore. So this was all we have discussed in the previous class. Now we will be moving on to today's lecture. Okay, so these slides I have explained to you. I will delete this slide. Let me just quickly delete this slide. Everything I have shared in the community already. If you want to see anything, you can just go and see from there. I'm deleting this slide from my PPT right now. It's become heavy. Okay, chalo. Let's begin with today's topic. So today we are going to continue after mole fraction. Till mole fraction, it was a important sector of this chapter. Now we will be moving on to a lesser important sector, but it is also not to be ignored. Why? Because from this you will definitely get this language in the question in some form or the other, whether you get in this chapter or you get in electrochemistry. But you will get a question of this type in 11th. You will definitely get in class 12. You may or may not get, but the language will definitely be in the question. So the next topic that we are going to start today, the first one is mass percent. Okay, the first thing we are going to start today is mass percent. So that is going to be my fifth part. We have done till 4. That is called mass percent. Mass percent, or we will talk about weight by weight percent. Weight by weight percent. Weight by weight percent. That is also called W by W percent. Right? So today we are going to study this one. So let us read. In questions you will find 20% solution, 30% solution. What does that mean? That basically means it is given mass by mass percent. That will be mentioned. 30% what? 20% W by W, or W by V, or whatever, V by V. That will be mentioned in the question. So if it is talking about mass percent or weight by weight percent, that means numerator also has weight, denominator also has weight. So what will be the formula that will arise from here? Can understand, I hope. The formula that will arise from here is, first let's write the definition, then I'm writing the formula. Definition says mass of solute, it is the mass of solute in gram if mass of solution, or I can write it is the mass of solute in gram dissolved in 100 gram of solution. Dissolved in 100 gram of solution. Did you understand? So how much solute will I dissolve in 100 gram of solution? That is my mass percent or weight by weight percent. Okay. So how will I represent this weight by weight percent now? Let us know that. So if I have to write W by W percent, then I will represent it by mass of solute, that is whatever the mass of solute that will be given to me, divided by the mass of solution, into 100. Did you understand? This is a very important formula. This is a very important formula. Please mark it. Very important formula. Mark it. Okay. Weight by weight percent, and it will be given. It means what? It means mass of the solute is given in the question, divided by mass of the solution, not the mass of the solvent. When we have seen molarity, there was mass of solvent, but here it is not mass of solvent. Here it is mass of the solution. That is, two differences are there. Little bit different. That you remember. Is it clear? So if I am talking about weight by weight percent, it will be mass of the solute divided by the mass of the solution into 100. It's a very simple one. Nothing to worry about. Done. This much only you have to know from here. Okay. Clear with this? Yes. Clear with this? This much only you have to remember. Nothing difficult from here. Okay. Okay. Next I am just telling you one small thing, that is the relation between which will be required for your JEE mains, NEET, advanced, all those. Okay, not NEET advanced. I meant JEE mains, advanced, and NEET. Okay, relation between weight by weight percent and molarity. Sorry, not molarity, and density of the solution. So there is a specific relation between weight by weight percent, molarity, and density. What is that relation? That relation will be used in NEET especially most of the times. That is, weight by weight percent into density into 10 divided by the molar mass of the solute. Did you understand? So again, it is an important formula. You have to remember the formula. So this is a simple formula to find out the molarity when weight by weight percent and density is given. You will be finding out the thing by using the mass of the solute. So this is the mass of the solute, weight by weight percent, density into 10 divided by mass of solute. Very very important formula. Mark it for short numericals, because this will not come in long numericals. Short numericals, mark it. Okay. Any doubt? Till now, any doubt? This should not be, it's easy one. Okay. Sure. Just give me 1 minute to load. Okay. Clear with this? Now, next one. This was mass percent or weight by weight percent. Now we have the next percent that is coming up is the volume by volume percent. Next percent is volume by volume percent. Volume by volume percent. It is V by V percent. So what is now this V by V percent? Like in case of weight by weight, we have seen to weight of solute divided by total weight. Here it will be volume of the solute divided by total volume. Simple, same thing. Definition will just change, right? So what is going to be the definition? Let us write the definition at first. So definition is going to be, it is defined as the volume of solute dissolved in 100 ml of solution. Dissolved in 100 ml of solution. Did you understand? So defined as volume of solute dissolved in 100 gram solution. Last time it was mass of solute dissolved in 100 gram of solution. Same thing, this language is changing, right? So what is going to be my V by V percent? You can understand? It's going to be volume of solute divided by volume of solution into 100. So right. Do you understand? Nothing difficult, right? Easy ones. Formula, remember. Okay. Volume by volume percentage is clear, I hope. Clear. Now, whosoever volume by volume percentage is asked, okay, I have written volume of solute. Maybe it is asked volume by volume percentage to solvent. Though it is usually given for the solute, might be given for the solvent also. That is not a very big deal. So in that case, we will write the volume of the solvent above. What is the big deal, right? So accordingly, you can just change. It's not at all a problem for you. It should not be a problem for you, right or wrong? Clear with this? Clear? Clear? Volume by volume percent. Alright. Next we have the strength of the solution. Strength, that is M by V. We were doing W by W. We were doing V by V. Now we will do W by V. That is the number 7. Number 7 we have mass, was that right? Percentage by strength. Percentage by strength. In practical you have learned strength. Titration, strength. What does strength mean? Moles per volume, that is strength. So here also we will be checking mass per volume, right? Actually it is mass per volume, but the unit is mole per liter, right? Where is molarity? It is actually telling molarity. Whatever. Percentage by strength, or I can say it as W by V percent. Okay. So if it is written weight by volume percent or percentage by strength, then always remember that it is meaning mass divided by volume. So let us write the definition. Ooh, baba. Ooh. So let us write the definition. So definition is going to be, it is defined as the mass of solute in 100 ml of solution, in 100 ml of solution, right? So how much mass I am dissolving in 100 ml, that is going to be my percentage by strength. Did you understand? All right, next. Percentage by strength formula. What is going to be the formula? Mass of solute in gram divided by volume of solution into 100. Clear? Clear? Formula important. Okay. Clear or not? Just check it out fast. Alright, so next. Let us move ahead. Percentage by strength done. Temperature effect I have already discussed. Percentage by this is done. Now we will be moving on to a very important part of this chapter, and gradually we are going on to the main part of the chapter. Before that, I have two unimportant things to say, but I will say only one, because actually two are there, but I will say only one. That is number 8. I have already written later number 9. Alright, number 9. Number 8 I think. I did write number 9. Alright, number 9. First let us discuss this, then I will go to the main part, that is the normality. This is going to be my number 8. See, I have already written this down so as to save my time. See here, this is parts per million. We write it as ppm, parts per million. This is used when the mass of solute is very less as compared to the mass of the solution. Right? Suppose the solution is very huge and you are giving a little bit of solute in it, so that's going to be like, suppose you have a 2 liter bottle and you are giving 1 gram in it. So you have a 2 liter bottle and you're giving 1 gram of solute in it, that's very less. Though it is not that less, but if I say you are giving 0.0001 gram in 1 or in 2 liters, then that is very less. So in that case, we'll be using parts per million to express that. See, percentage when we are expressing, that is weight by weight percent you go, or volume by volume percentage you go, or weight by volume percentage you go, all that part we are multiplying by 100. So we have just changed our reference point. We were discussing till now that in 100 gram or 100 ml how much solute or solute we are dissolving, right? Now we have just changed the perspective of that. Now we are taking, instead of 100 gram, we are taking 10 to the power 6 gram, or 10 to the power 6 parts, rather. That is a 1 million part. We are taking 1 million part. Why? Because the quantity of the solute that is dissolved is very less as compared to the total mass of the solution. That is the reason we have to consider special thing. Now parts per million is there. Similarly, parts per billion will also be there. But billion we are not reading. Billion we read. Billion also will come. So ppm is mass of solute by mass of solution into 100. No, we are not taking 100. We will take 10 to the power 6. Clear? Clear? Similarly, if it is ppm by volume, then we will simply take volume of solute by volume of solution, right? If it is mass, then mass divided by mass. If it is volume, then volume divided by volume. Same thing, no change, only both the conditions should be same. That is, numerator denominator should both be volume and mass. Like one is volume, one is mass, will not be accepted. Okay, ppm is clear. I think ppm will not create much tensions with you, right? Then ppm is clear. All right, chalo. Next one. After ppm, we will be reading the last concentration term and the most important concentration term, that is normality. But before learning about normality, you need to know about what exactly is equivalent mass and how to calculate equivalent mass, because that you have not done in class 11 properly, I know very well. So you need to first know. Okay. Now first tell me, what exactly do you mean by equivalent weight? Though I should not tell in much details about equivalent weight right now, because that is a part of class 11 and not class 12, because class 12 has a lot of other things to do rather than doing all this. But still I will just say, because you should know. So what exactly is equivalent weight? You have learned in class 11 what is equivalent weight. So now let me ask you all, what is equivalent weight? Equivalent mass is basically the mass of a substance. Listen to me very carefully, because I am saying very slowly so you can understand it. Equivalent mass of a substance is that mass which will react or displace or produce three conditions. Either it will react, or it will displace, or it will produce 1 gram of hydrogen, it is exactly 1.008 gram of hydrogen, or 8 gram of oxygen, or 35.5 parts by mass of chlorine. So if either of these three conditions is satisfied, then we will call that particular amount of mass as the equivalent mass of that particular substance. Did you understand? So if I talk about the definition, then definition is this much, that equivalent mass of a substance is the mass which will react or displace or produce 1.008 parts by mass of hydrogen, 8 gram or 8 part by mass of oxygen, and 35.5 parts by mass of chlorine. Very very important, this definition you have done in class 11. So let's write it down. Though I should not discuss this in class 12 again, but I have to, you know. Equivalent mass. We'll just calculate a few equivalent masses. I will tell you how to do that, and you can just move on to normality. Equivalent mass. So what is the definition I told? It is the mass of substance. It is the mass of substance that reacts slash produces slash displaces 1.008 gram, not gram, parts by mass of hydrogen, or 8 parts by mass of oxygen, or 35.5 parts by mass of chlorine. Okay, so this is a basic idea of what exactly is equivalent mass. Now based on this you will be getting numericals. No, not on equivalent mass. Directly you will not get numericals, you will get numericals in finding out normality. There you need to find out equivalent mass. So you have to know how to find out equivalent mass. So let us now know how exactly we will find equivalent mass. So equivalent mass, let's now understand how to find it out. Okay, equivalent mass has variety of formulas. Whether the question is asking a compound, or it is asking a acid, or it is asking a base, or it is asking a atom, ion, whatever, different formulas will come out. But the main formula that I am telling you, that will be common for everyone. What is that? Equivalent mass. I am writing EQ mass, huh? Because every time I cannot write this big word. So equivalent mass will be equal to molar mass, divided by its n factor. Do you understand what you write? Right. Molar mass divided by its n factor. Now what exactly is this n factor thing? The question is striking your mind, what is this n factor thing? N factor is basically going to vary for every given compound. Every given compound. This n factor only we will calculate, and based on n factor we can calculate the mass of equivalent mass of everything. Now just briefing you about the n factors. In a very quick way I will brief. See, if it is a atom, then n factor of that particular atom is going to be its valency. It is going to be its valency. Now see, atom only? No. Cl2, O2, these are also going to exist in that form. They cannot exist at their atom state. So valency. Valency. Atoms. So I can write atoms or covalent compound or covalent molecules. Okay, covalent molecules. I'm not mentioning compounds. So it can be atoms or covalent molecules like hydrogen, H2, N2. This cannot exist as only N, or this cannot exist as only O. So you have to write it as O2. So the moment you write as O2, its n factor is going to be the valency of that particular thing. Okay, clear? Okay. Number 2, if it is a base, then what is going to be its n factor? In class 10 you have learned, for a base it is acidity, for an acid it is basicity. So it is going to be its acidity. Now don't ask what is acidity, because I cannot do that, I cannot discuss that now, otherwise your syllabus will be incomplete. Next, if I have to talk about acid, then it is going to be basicity, right? Number 4, if I talk about ionic compound, then n factor is going to be the charge on cation, total charge on cation, total charge on cation. Number 5, if I am talking about ions, it is going to be n factor is going to be charge, mode of charge. Now you end up writing minus plus, no, it is going to be mode of charge. Now if it is a redox reaction given, redox reaction, this will also be given, redox reaction. Sometimes you will get redox reaction, then n factor is going to be number of electrons, number of electrons. Redox reaction means oxidizing agent, reducing agent, so they are all going to be indulged with transfer of electrons, so number of electron change. So this will be basically oxidizing agent or reducing agent. Oxidizing agent OA, I'm writing OR for OA and RA. Clear? Oxidizing agent, reducing agent, if it is given KMnO4, what will you do? You have to first see what medium it is given, and accordingly you have to find it out. Okay, so if it is a redox reaction, it is oxidizing agent or reducing agent, then n factor will be the number of electron change. Okay, I did not mention that, sorry. Number of electron change, number of electron change, very very important. So these are the quick notes of equivalent mass calculation, so please make sure that you know all this. Okay, so based on this you can calculate the equivalent mass, and the moment you calculate the equivalent mass, you are well ahead, you are well prepared to move on to the next part, is a normality. Now before moving on to normality, again I have to say something else. What is that? That is basically your gram equivalent mass. Just like number of moles we have calculated, given mass divided by the molar mass, similar way, or the corresponding thing of moles in equivalent mass will be the same thing of, or the corresponding thing of the moles in equivalent mass is going to be gram equivalent. So if I have to calculate, so I am writing over here, if I have to calculate gram equivalent, then what it will be? It will be the given weight divided by equivalent mass. Gram equivalent can also be called as chemical equivalent. Okay, very important formula because this one will be using. Clear? So if we have to find out the gram equivalent, number of gram equivalent, then that is going to be given by equivalent mass. Simple. Number of moles we have found out using given by molar mass. Here just molar mass replaced by equivalent mass. Clear? 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 Any doubt? No doubt. But before I move on to normality, I need to show. I will just give you two questions on equivalent mass. So let's just discuss one question. Suppose you have no, let's not take this equation. It's a very common one. Okay, let us take the equation uh, CH4 plus O2. CH4 plus O2. What will happen? Organic reaction, basic reaction, all hydrocarbons will produce carbon dioxide and water. So it will produce CO2 plus water. We need 2. Need 2. Okay, now see, methane's mass is 16 gram. Oxygen's mass is 64 gram. No, it is 32, but coefficient is 2, 64 gram. Carbon dioxide is 44 gram. Water 18 into 2, 36 gram. Okay, this much basic stoichiometry calculation you should be able to do from class 10. Alright, okay. Now, from the definition of equivalent mass, we have told what? That either react or produce or displace 8 part by mass of oxygen. So you can see 64 gram is there. So if I write 64 gram oxygen reacts with 16 gram CH4. So how much 8 gram oxygen will react with? 8 gram oxygen will react with 2 gram CH4. Right? Simple unitary method. Huh? Simple unitary method. So if I am saying that 864 gram O2 reacts with 16 gram from the given equation, then 8 gram must react with 2 gram. But 8 gram O2 সাথে যে react করে, it is the equivalent mass of CH4. So equivalent mass of CH4 in this equation is 2 gram. Did you understand? This is equivalent mass of CH4 in this equation. Okay, see, equivalent mass jar tar jokhon tokhon bar kora jay na. Whenever you can find out the equivalent mass, we will find out the equivalent mass. If it is a reaction given, then reaction অনুযায়ী we can find out using this way. Okay, okay. Now I have to find out the equivalent mass of carbon dioxide. How will we find? Same way we will find. Use the unitary method. So how? So let us see. 64 gram O2 forms 44 gram CO2, right? So 8 gram O2 will form 44 by 8 gram CO2. So whatever will the value will come, 44 by 8, that is going to be my equivalent mass of carbon dioxide for this equation. So this is going to be my equivalent mass of CO2 in this equation. Any doubt? Any doubt? This is a basic idea I'm giving you of equivalent mass. Okay, let me clear. 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 Okay, chalo. Now let's move on to the next one and the last concentration term, that is normality. Normality. Now we are coming to the concentration term number. Now we'll find normality is very easy. After knowing all this, now we'll find normality is nothing. It's a very easy one. Normality N. Normality N. So normality is basically defined as the number of gram equivalent in 100 ml of solution. So what is the definition? The definition is, it is defined as it is defined as number of gram equivalent number of gram equivalent in 1 liter of solution. Gram equivalent in 1 liter of solution. In 1 liter of solution. So in 1 liter, how many number of gram equivalent of the solute is present? Oh, of solute, sorry. Of solute, of solute in 1 liter of solution. Clear? Easy definition? Right. Next formula. N equals to number of gram equivalent divided by volume of solution in liter, right? So this is going to be my important formula. Okay, this one only I can expand and write N equals to number of gram equivalent. Just now we have calculated it to be the weight, given weight divided by equivalent weight of B into volume into 1000, right? So this is another formula which you can just derive it from here. Nothing very difficult to derive, right? Clear? Okay. Last one is, I can say, normality is dependent on temperature. Can I say that it is dependent on temperature? It is dependent on temperature because again the volume factor is coming up, so it is definitely going to be dependent on temperature. Tell me, clear with this or not? With this we have come to the end of the concentration terms, but I will just give you a chart and then I will just move on to the next topic. Okay, clear with this? Yes, clear with this? বোঝা গেছে? বোঝা গেছে? বোঝা গেছে? বোঝা গেছে? Okay, chalo. Next I'm going to just give you a relation between normality and molarity. Relation between normality and molarity. Relation between normality and molarity. Very, very important relation, huh? Star mark it, whatever mark it. Very, very important. Many a times this will be asked. What is the relation? Normality equals to molarity into n factor. Molarity into n factor. Very, very important. Normality equal to molarity into n factor. Very important. So sometimes you will find molarity, you can easily find out, normality are having problem. So in that case you find out the molarity and multiply that with the n factor of the given compound to get the normality. So you do not have to take too much stress. It's easy. Alright. Okay, next you will get in some time in the question paper you will find some terms. Just I'm writing some terms. Suppose you get a term called decinormal solution, or you get a decimolar solution, or you get a decimolal solution. So this all means n by 10 or m by 10 or m by 10 or small m by 10. So if it is given deci, then divide by 10. Whatever is given, divide by 10. If it is given normal, then n divide by 10. N will be given that value. Okay, n divided by 10. If it is given molar, that will be m divided by 10. Okay, so if I am talking about deci, then it will be divided by 10. That means the given normality of the solution will be 0.1. The given normality of the solution will be 0.1. Given molarity of the solution will be 0.1. given molality of the solution will be zero point 0.1. So this you have to understand from here. So this is going to be nothing but 0.1. Okay, next. Decinormal you got. Next sometimes next sometimes you will get centinormal. Next sometimes you will get centinormal, or you will get centimolar. Very rare centi is given, but still. Then you might get centimolal. Then what? Deci is divided by 10, then centi will be divided by 100. So it's going to be n by 100, or it is going to be m by 100, or it is going to be m by 100. So this is nothing but basically it is 0.01. So a better version of writing 0.01 is basically you write centimolar or you write decimolar this way. Right? So it's basically a stylish way of writing. Same thing we are trying to represent in a different way. That's all. Okay, next is semi semi-normal, semi-normal or semi-molar or semi-molar. What is semicircle? Semicircle means half of a circle. So what will be semi? This is also going to be half. So it is going to be n by 2, or it is going to be m by 2, or it is going to be m by 2. So what is it actually representing? It is actually representing a 0.5 solution. 0.5. So instead of writing 0.5, I can directly write it as semi-normal, semi-molar or semi-molar solution. You should be able to recognize that it is talking about what value. Okay? Doubt? Doubt? No doubt? Okay. Good. Next, moving on to the next topic is law of equivalence. Is law of equivalence. See, these topics are of class 11, not of class 12. These topics are of class 11, not of class 12. The class 12 part we have not started. Actually, the class 12 part which begins from solubility, we have not started that yet. We start from solubility. We have not gone to solubility yet because before that also a lot of things need to be said. Next topic we are coming up with is law of equivalence. Law of equivalence in class 11 it was clearly given in the book, law of equivalence. So let's read about law of equivalence. Okay, law of equivalence. Heading, law of equivalence. Do you remember what exactly was law of equivalence? I guess you don't, so it's fine. Law of equivalence states that in a chemical reaction, gram equivalent of reactant reacting will be same as the gram equivalent of product that will be produced. Number of moles might be different, that is a different concept. But the gram equivalent of the reactant that is reacting will produce the same number of gram equivalent of the product. It cannot happen that 1 gram equivalent reacting with 2 gram equivalent of, forming 2 gram equivalent of product. No, 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 definitely not. So what does law of equivalence state? Law of equivalence state that in a chemical reaction, gram equivalent of reactant is always equal to the gram equivalent of products produced. It's always equal to the gram equivalent of product produced. Clear? So law of equivalence is stating that in a chemical reaction, gram equivalent of the reactant will always be equal to the gram equivalent of the product that will be produced. Any doubts? Any doubts? Any doubts? No. Clear with the law of equivalent? Right. You remember one term was there, it's called limiting reagent. So what is limiting reagent? Limiting reagent is that person who has the least gram equivalent. So least gram equivalent compound, sorry, least gram equivalent reactant. You will calculate the gram equivalent of reactants. Whichever reactants gram equivalent will come lesser, that is going to be the limiting reagent. So least gram equivalent reactant will be limiting reagent. Will be limiting reagent. Clear? So the least gram equivalent reactant will be the limiting reagent. That means it will be limiting the reaction. You know what is limiting reagent? That I need not explain now. Alright. We have some simple questions from here that we will be doing at the end. Okay, we have some questions on this and one formula that I will say when it is required. Right now we are not doing questions on this, so we'll be moving on to the next part. Okay, clear with this part? Any doubt till now? Just mention. ডাউট থাকলে বলো তাড়াতাড়ি, বল তাড়াতাড়ি ডাউট থাকলে। I'm just giving you 1 minute just to make sure that it's clear. Giving you 1 minute time. Let's get it done. Give you 1 minute time. Then we will be going on to the questions. We'll going on to the questions. Just say 1 2 formulas and we'll move on to the questions. Okay. So that now let us come one by one. Let us solve the questions. Okay. We are done with the theory for the day. Let us solve the questions. After the questions, I will be telling you a little bit introduction to the next part. Is the class 12 part will be starting after this lecture. The first lecture, the second lecture is mostly of 11th part. Okay. Third lecture onwards, we will be entering into the class 12 parts. Okay. Today I will be introducing solubility and tomorrow it will be completely based on class 12 parts. Okay. Achha. Before I start with certain numericals, let me give you two formulas. I think you already know. This is called dilution equation. Dilution equation. Dilution equation. This is specifically used for certain specific type of questions. Don't everywhere use this formula. This is used for specific type of questions only, where you will find like the question types will be find volume of 6 normal HCl which is required to prepare 3 liter of 2 normal HCl. This type of question where it is required, you can use the dilution equation. So dilution equation is basically having two parts. One will be M1 V1 equal to M2 V2 and second one is N1 V1 equal to N2 V2. Only these two formulas just you need to remember. Okay, 1 and 2. Next, another concept, let me just tell you, which you can better understand when you solve questions actually. I was not trying to tell you till now, but let me just help you. I think there won't be any problem. We'll do numericals. So if you don't understand now, it's not a big deal because we will do numericals, then you will understand it. Okay. Concentration of mixtures. The heading is concentration of mixtures if they react with each other. If they react with each other. Okay. अच्छा चलो, I will tell you it. Let one sum come, then I will tell you. Otherwise, you will think what am I saying? Let one sum come, then I will tell you. Okay. Let the heading be there. Let one sum come, then I will tell you about this. First, let us start doing with the basic sums. Then we'll come to this. Okay. चलो. Where did the sums disappear? Sums. Okay. Okay. चलो. I am giving you 1 minute time for this. Just try out a question, and then I'm going to start. Okay. 1 minute time for this question. What is the question saying? Question says, what is the mass percentage of carbon if 22 gram of benzene is dissolved in 122 gram of carbon tetrachloride? It's the basic question possible on weight by weight percent. What is told? Mass percentage is asked, carbon tetrachloride. 22 gram of benzene is dissolved in 122 gram tetrachloride. So just now we have read that weight percent is equal to what? Mass of solute divided by mass of solution. So mass of whom? Of solute divided by mass of solution into 100. So mass of solute is basically 122 gram divided by, actually here it is not the mass of solute. If you can see, carbon tetrachloride is not the solute, it is a solvent. So it is going to be the mass of solvent. Okay, 122 divided by 122 plus 20 is going to be 144 into 100. If you calculate the percentage, you will get 84.72. I'm guessing 122 by 144. It is going to be 84.72%. So option number 1 is correct. Okay, clear? Clear with this? It's an easy question. Directly it is coming. Okay, let's try out the next question. Just let me save it. Give me 1 minute. Next question is here. This is also a very easy question. So let's give 1 minute. Take 1 minute, solve the question, then we'll discuss. Alright, chalo. Now let's take up the question. What is the mole fraction of glucose in 10% wet by wet solution? Now just some time back I have discussed 10% wet by wet percent solution and mole fraction is being asked. So what is going to be the answer? This glucose solution. This is a very easy one. Mole fraction of glucose in 10% wet by wet glucose solution. What does 10% wet by wet glucose solution mean? First we need to know that. 10% wet by wet glucose solution means 10 gram of glucose present in 100 gram of solution. Right? If you cannot analyze this thing, then it is a problem for you. You have to analyze this thing, because in solutions you have to define your own solution, because in the question will not be given solutions total mass and all this. You have to define your solution. Question is not giving you the solution directly. Question is giving you the solution's name and is giving you percentage or something like that. You can define your own solution. You can define your own solution, right? Exactly what is there we don't know, but we can define solution. We can say that 10 gram of glucose is present in 100 gram of solution. That is only 10 by 10%, right? So if 10 gram of glucose means 100 gram of solution, then weight of this solute is going to be 10 gram. So what is going to be the number of moles of glucose? Is going to be 10 divided by 180. I have glucose mass is 180 only. 180, right? And what is going to be the WA? The WA is going to be 90 gram, right? Because 10 gram is glucose. So remaining 90 gram is water. So it's going to be Na. There is a solvent. Is going to be how much? 90 divided by 18. So that's going to be 5, right? So if I have to calculate the mole fraction of B, so that's going to be 1 divided by 18 divided by 1 by 18 plus 5. So that's a simple calculation. Okay. So 1 by 18 as far as I can guess is 100. So it will be 100, two zeros will come 0.05 divided by, should be 5. This should be 5 plus 0.05, right? Okay, 5 plus 0.05 will be 5.05. 5.05. Okay, so this is going to be 0.05 divided by 5.05. So it we can write it as basically 0.01. Okay, so your answer will come option number A, 0.01. It will not come exactly 0.01, it will come around 9.99 something like that. So if you shift the decimal to one place, it will come 0.01. Okay, it will come around 9.9 like this, something like this. It will come 9.21 minus 3. So you shift it, so it will become 0.099, right? It was 9.9, so 0.099, so it is 0.01. This one will be repeated. Okay, so it will not come directly. Don't think that it will directly come 0.0. No, it will come 9.9 to minus 3. Approximation you use will get 0.01. Okay. Yes, understood. Easy question, but you have to assume the solution first. If you don't assume the solution, they are only thinking, কি করবো কিছু তো বুঝতে পারছি না কি করবো, that you have to think. Otherwise, you will be stuck in the first part of the question only. Next. Okay, marginal percentage they are asking. Just it's easy one. Again, it's easy one. Let's do it. 1 minute. Start. Let's see what the question is saying. Okay, question is saying Rashida dissolved 40 gram of sugar in 600 ml of sugar solution. Okay, very good. Calculate the mass by volume per C. Direct nonsense question they have given. So it is given mass by volume percentage. So mass by volume percentage. Let's write the formula. What is the formula? Mass of solute. It is asking for the solute divided by volume of the solution divided by volume of solution into 100, right? So what is the mass of the solute? 40 gram. What is the volume of the solution? 600 ml into 100, right? That will be 0 0 0 0 to be 2. That's going to be 3. So it is going to be it's going to be 20 by 3. So it is going to be 6.66. So that's option number 3, right? 6.6 only 6.66. So option number 3. See, if there is any mistake from my part, please correct it. Okay, I'm not seeing any solution you're doing, so please correct it. Might be wrong, but I don't think it will be wrong. By chance, if it becomes wrong, please make sure that you correct it from your end. Okay, clear with this question? Easy one. Next one. Try it. 1 minute. Okay, time is up. Let's see the question. The question is mole fraction of solute in benzene is 0.2. Then what is going to be the molality of solute? If mole fraction is given 0.2, then what is going to be the molality of solute? Okay, okay. See, what is given first, let's understand. Given is inside benzene, so benzene is a solvent. Okay, so in benzene, this mole fraction of solute in benzene is given 0.2. So it is asking what is going to be the MB value of this. Okay. From psi B, can I find out psi A? What is going to be psi A? 0.8. Even if you use some part of your brain, you can say that psi B equals to 1 minus psi B, right? Psi A equals to this. Now I have told you that molarity formula with mole fraction is psi B by psi A into 1000 divided by volume. Told this, right? So psi B by psi A is basically what? It is basically 0.2 by 0.8 into 1000. Let me check the relation once. Means something wrong. Which just let me check the relations. Oh, it will not be here. Just a minute. Anyways, I don't do. Okay, okay, chalo. Volume will not come. Why am I writing volume first? That is what I am thinking. Why volume I have written? Molarity will come, then volume will come. So 1000 by mA. So what is the molar mass of benzene? Molar mass of benzene is 78. Make sure that you know that. Okay. So it's going to be divided by 4. So it's going to be around 25, 250. It will be 250 divided by 78. Okay, 78 to 50. 78 and 250. 78 3s are 4, 2, 3. 3, 234. 4, 2, 21. No, sorry. 21, 230. Correct, correct. 234, it will be 6, 9 by 6, 66. 66 is 0 point. What 66? Mad or what? 250 it was. 5. You 160. 160 means 2. 2 is basically 156. 3.2. So correct answer will be 3.2. First option. Okay. There will be 3.2. Okay. So how did we calculate? I saw that psi b was given. So if psi b is given, I have to find psi a. Then I can get to molarity because I have the relation between molarity and mole fraction. Okay, clear? Can you go to the next question? Okay, next question. Next question is a question of JEE mains. So I'm giving you 1.5 minutes to attempt the question. So I'm giving you 1.5 minutes to attempt the question. Okay, so time is up. Let us discuss the question. Let us read the question first. What would be the molality of 20% aqueous Ki solution? 20% aqueous Ki solution. So first let us create our own solution or define our own solution. 20% aqueous Ki solution means 20 gram of Ki present in 100 gram of solution, right? So I have to write WB equals to 20, not West Bengal, please, not West Bengal. So WB equals to 20 gram. So what is WA? It is going to be 80 gram, right? So what is going to be NB? NB is going to be 20 divided by 166 given, and Na is going to be 80 divided by 18, right? What I have to find is molality. What I have to find is molality. So I don't need the Na part because mole fraction they are not asking. So Na part not needed. Na part I show you, but Nb part will be needed anyway. So Na part is not needed. Fine. Can I simplify this? Yes, I can. So it is going to be 10 by 83. 83. Okay. Now molarity is equal to what? Nb divided by weight of the solvent into volume I'm writing again. Weight of the solvent into 1000. So can I write 10 divided by 83 into weight of the solvent is what? 80 into 1000. Right? Now let's perform some operations. So it's going to be 2, it's going to be 25, it's going to be 5. So it's going to be 125 divided by 83. 125 divided by 83. 83 and 125. 83 twos are 6 is to 16 more. So 83 1 2 4 42. Okay, 42 means point 10 will come. So 83 4 4 3 0 32 10 no 5 5 45. So it 1 5 5 will be 5 1 4 1 415 5. Okay, it will be coming around 1.5. Okay, it will be coming around 1.5. Necessarily 5, necessarily 50, so 1.50 something. I'm not checking that, so it will be 1.5 exactly. Just check it out. It will be around 1.5, 1.51 probably. 50 then 6 will come, I think, whatever. So it will be around 1.5. Clear? Clear? How did we do it? Is it clear? So we have defined our own solution, because without defining my own solution I cannot proceed with the question only, because we don't know what is the real solution. What app are you teaching? It's a writing app. You'll not get it easily. It's a very hidden app. Okay, anyway, next question is here. You have 1.5 minutes to try out this question. Here you go. The timer starts. Try. Okay, let's see what the question says. Let's see. 5.2 molal aqueous solution of CH3OH is supplied. What is the mole fraction of CH2OH? Okay, so what is given us to in the question is molality equal to 5.2, right? Aqueous solution of CH2OH is given in the question. Okay, okay, I have to find out the one mole fraction. Now you see, in the formula of molality you had psi b by psi a, sorry, psi a into ma into 1000, right? Now if I can transfer this psi a in terms of psi b, then I will have only one variable to find out, so I can find out easily. Understood what I am trying to mean? This psi a, I can transfer it in this format, psi b, 1 minus psi a, 1 minus psi b. So one variable, find out the answer. So it's very easy one. So 5.2 I can write. First let me write the formula so that you don't ask me what did I do. M equals to psi b divided by psi a into 1000, sorry, into MA divided into WA into 1000. Why am I writing W? MA. Okay, now what I will be writing is, instead of this I will write 1 minus psi b, so that I am getting the answer in terms of one variable only, so it becomes easier for me to solve. So 5.2 equals to psi b is asked, so psi b will be asked into MA into 1, 18 minus 18 into this is 18 psi b. Okay, I'm erasing this part. Okay, continuing the calculation. So 5.2 multiplied with 18 is 5.2 multiplied with 18 is 93.6. So it is 93.6 minus 93.6 psi b equal to 1000 psi b, right? So it's going to be 1000 plus 93.6. It will be 1093.6, I hope, right? So 93.6 equal to 1093.6 psi b. So from here can I write psi b equals to 93.6 divided by 1093.6, going to be 0.086. Okay, clear? Understood? What did we do? We were supposed to find out the mole fraction. So what did we do is, we transferred the mole fraction of water in terms of mole fraction of CH2H, so that I can get one variable, and solving one variable using one equation is quite easy. So we have done that. Alright, alright, alright. Next question. We have plenty more questions. Next question. Next question, I'm giving you exactly 2 minutes to solve the question. The JEE Mains 2019 question. Even if I say the name of the app, they also will not get it, because it is extremely hidden. Will not get it at all. I myself went mad to find it out. Okay, solve the question. Solve the question. Solve the question. Okay, try out, because these are no, not very tough questions. Advanced question might be tough. These are mains question. Now let's see what is the question. Let's read the question. 100 gram of C3H8 is completely reacted with 1000 gram of O2. Okay, ঠিক আছে. The mole fraction of CO2 in resulting mixture is X into 10 to the power minus 2. What will be the value of X? Okay. The question is easy, but the calculation might be a little big. Why? Because it involves a little bit of class 11 concept, and that I have already revised you today. Today also to the second day I was revising class 11 only because class 12 paper started also today also. Start with solubility, that will be tomorrow, but today also we cannot start. Okay. Now first let us write the reaction because that's the first thing in this case. 100 gram of C3H8. So let us write the reaction. Achha, first let me copy the slide because I will need a few copies of this slide here. Okay. Just give me a minute. If the entire file gets deleted, I will go mad. Better to save the file. Okay. Reaction is C3H8 plus oxygen forming CO2 plus hydrogen water. Don't say that you don't know the reaction because every hydrocarbon gives you CO2 and water only. That much so you all know, right? Okay. Now you have to balance the reaction. So let's balance 3 carbon. So let's put over here 3 carbon. So if I put 3 carbon, then I will get 6 plus 1 7 not available. So 10. I can put 10. So this will be 3 3 6. 3 6 no. I have to put 8. So it will be 4. 4 plus 6 is 10. So 5. Then balancing done. Now we have to see what is given in the question. 100 gram of C3H8 completely reacted with 1000 gram of O2. Now will 100 gram react with 1000 gram or not, that we don't know. So we have to check. So we have to find out if there is the limiting reagent of this reaction. Who is the limiting reagent? How will you find out the limiting reagent? Limiting reagent find করার জন্য there is one condition. So first let's find out that number of moles of C3H8 বার করি আগে. C3H8 এর number of moles কত হবে? It is given 100 gram, and if you calculate the molecular mass in 12 to 30 12 to 36 and 8 44. So it's going to be 44. Okay. Okay, this is going to be 2.27. Next, NO2, number of moles of oxygen given 1000 gram divided by 32 is the mass. Okay, so we don't need a calculation right now. Leave it. Skip it up to here. Okay, now we are finding out the limiting reagent. Who is the limiting reagent? To find out the limiting reagent, we use a door. Baba, get deleted now. Why are you coming by every time? Oof. See, imagine the condition. Deleting it every time they are coming back. Okay, now you see limiting reagent. Who will be the limiting reagent? I don't know. So let us find out C3H8 also, and let us find out O2 also. Whosoever will have lower value, that will be the limiting reagent. Okay. How to calculate limiting reagent? You can calculate by number of moles, okay, divided by stoichiometric coefficient. Number of moles divided by stoichiometric coefficient. Class 11 topic, huh? Don't ask me why and where it is coming from. Limiting reagent, if you have to check for, then you find out both the reactants, this value, number of moles divided by stoichiometric coefficient. Whoever will give lower value, that will be the limiting reagent. So this was 100 divided by 44 into 1. Nothing was there means 1. And this was 1000 divided by 32 into 5. So can you see that denominator is this denominator is bigger, so value will be lesser. So who is the limiting reagent? Who is the limiting reagent? Clear? Clear? So limiting reagent is C3H8. LrO2, the value will be bigger. You check it out. You check it out. 100 by 44 is bigger. 100 by 44 is bigger, or 1000 by 30.5 is bigger. Who is bigger? Denominator is increasing, na? Then, if you have any problem, then you can multiply 1000. Can I write like this? Now tell me, whose denominator is more? Whose denominator is more? Value will be lesser. This value will be more. Clear? So LrC3H8 will be the correct one. Understood? So who will be the limiting reagent? C3H8 is the limiting reagent. C3H8 is going to be the limiting reagent. Any doubt? Any doubt you guys have? Doubt? No doubt? So whoever will have the higher value, that is going to be the limiting reagent. So LrC3H8 is the limiting reagent because this value is more than this value. Sorry, less than this value. What am I saying? Whoever will have the lower value, that is going to be the limiting reagent. So if I am going to see 100 by 44 and 1000 by 32.5, then who will have the lesser value? 100 by 44.1, that will have lesser value. Obviously it will have lesser value. This no need to write. Okay, so LrC3H8 is the limiting reagent. So this is my limiting reagent. So whatever calculation now I will proceed with, I will be taking into consideration C3H8 and not O2 value. Okay, clear? So 100 divided 44 into 1. Okay. Now let us see. In the reaction that we have just now seen, we can see 1 mole reacts to form 3 mole CO2. So can I, because CO2 is required, so can I write 1 mole C3H8 forms 3 mole CO2, right? And this value, where it go? This one. This value is 2.27. We calculated already, and this value, no, not this value, sorry. This value will come 31.25. Okay, this value will come 31.25, and this value also need to calculate. Now this will come 11 point something as I'm getting. 1000 divided by 32, right? 1000 divided by 32. 31.25. Oh, write it over here. Not this. 31.25. This is 31.25. Done. So 2.27 mole C3H8 I will consider. So that will react to form how much? That will react to form 6.81 mole CO2. Done. Next, 1 mole C3H8 reacts with 5 mole O2. So if I have to consider 2.27 mole C3H8, then that will react with how much? That will react with 11.35 mole of O2 only, right? So how much number of moles remain unused? So here I am writing remaining moles equal to 30, how much was there? 31.25 minus 11.35. So that is basically 19.9. So this much number of moles remain. So when we will calculate the mole fraction, that time this has to be considered. That is the case. Understood? So basically what we have done is a mixture of class 11, class 12. Simple. First we have written the reaction. Then we found out who is the limiting reagent. We found out who is the limiting reagent. We found out that C3H8 value is lower, so it is a limiting reagent. Got it? So now all calculations are to be done from the C3H8 perspective. Now it's easy one. 1 mole C3H8 reduces 3 mole CO2. So how much will 2.27 do? 1 mole C3H8 gives 5 reacts with 5 mole O2. So how much it 2.27 will react with? We got that the value is 11.35. So we subtracted it and we got the remaining number of moles. So the remaining number of moles we got is 19.9. Now we have to find out what the mole fraction of CO2 in the resulting mixture. So mole fraction of CO2 will be equal to what? Number of moles of CO2 divided by who is remaining. Number of moles of CO2 is there, number of moles of O2, that is the remaining value only, okay, and number of moles of water. So let's calculate that. Number of moles of O2 we got 6.81, so it is divided by 6.81 plus water mole 9.08 and 19.9. Water how did we get? Calculate here, calculate from here only. So 1 mole C3H8 reacts with forms how many? 4 moles of water. 4 mole of water. So 2.27 mole C3H8 will form 9.08 mole of water. Okay. So now just do this calculation. You will get it as 0.19. So can I write this one as 19 into 10 to the power minus 2? So this is my x. So x equals to 19. Clear? You can see it is taking a little bit time to solve because I am solving step by step. Otherwise, it will not take that much time to solve in the exam. Okay? So did you guys understand what you have to do? So it's actually a mixture of class 11 and class 12 question. This is how class 11 and class 12 questions can be clubbed. Understood the question? Next question is JEE Advanced 2011. If it is an advanced question, then definitely it will take some time. Okay? Definitely it will take some time. So no need to worry about that. So let's read the question and try to solve it. Okay, not all advanced questions are difficult. Some are very lengthy, some are short. That depends on what the question is. So I am giving you exactly 2 minutes to solve the question. Write the question with a very advanced question. Analyze the question. Okay, this is a very advanced question. So you have to first analyze the question, then only you can solve. J advanced directly does not ask anything. Okay. Okay. There is the time is over. So let's now see what the question is asking us to do. Okay. Dissolving 120 gram of urea molecular weight 60 in 1000 gram of water gave a solution of density 1.15 gram per ml. Okay. First, you have to understand what is the question giving us. That means what values do we get from the question that can be of our use. First, you have to identify those values. So first, let us read the question once again. 120 gram of urea. So I have got weight of urea 120 gram. Next, molecular weight of urea also is given in the question. So that is Mb equal to 60 gram. Very good. So can I find out the number of moles of urea? Number of moles of urea is 2. Very good. Next, in 1000 gram of water. So weight of water is given as 1000 gram. Very good. Weight of water is given as 1000 gram. Okay, chalo. Next, solution of density. Density of the solution is given as 1.15 mole. So can I write the mass of the solution? That is, mass of the solution means mass of both A and B. Do not think that mass of solution is only mass of A. No, mass of solution is both mass of A and mass of B. So instead of M, I am writing with B, otherwise it will become molar mass. So weight of A plus B equal to, can I write WA plus WB, right? So what is basically WA? WA is basically 1000 and WB is basically 120. So can I write 1120 gram is the total mass of the solution. Now can I find out the volume of the solution? Volume of the solution will be density divided by mass of the solution. Density divided by mass of the solution. The mass divided by density. What nonsense am I writing? Mass divided by the density of the solution. So weight of A plus B divided by density of the solution. So can I write 1120 divided by how much? 1.15. So that gives me how much? Let's see. We'll do it later on. Now we are finding the molarity. So molarity will be basically NB divided by volume into 1000. So now let us do the calculation. So it's basically 2 into 1000 into 115 উপরে চলে গেল divided by 1120 into 100. This two zeros come. Tuk, 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 tuk. Okay. Now calculation you will do and you will get 2.05. Okay. Did you understand what you have to do in the questions? You can see all the J advanced questions are not the of that level which you're thinking. This is also the advanced question, but you can see that one page it is done. Because the question was like that. Okay. This I copied one time, no? Delete that. Okay, let us check the next question. This is a JEE Advanced 2016 question. JEE Advanced 2016 question. So for this I will give 2.5 minutes because this is a little bit big one. Means not that big, but you have to think a little bit. So I'm giving 2.5 minutes for this question. Do I think it's too much? Okay, try out the question. start and let's see what the question means. Okay, the mole fraction of solute in a solution is 0.1. First, let's note things. Mole fraction of solute. So, mole fraction of solute is 0.1. So, I can find out the mole fraction of solvent, that is 0.9. Okay. 298 Kelvin, molarity of the solution is same as its molarity. So, molarity is same as molality. Okay. Okay. Molarity is same as molarity. Fine. Density of solution at 298 Kelvin is given as 2 gram per centimeter cube. So it is asking for ratio of molecular weights of solute to solvent. Okay. What will we start with? See, molality and molarity both are same. So we have to find in terms of mole fraction, molarity and molarity one time. In molality we'll get Ma and in molarity we'll get Mb. So two relations you have already got, solve those two relations. Okay, so how to solve? Let us start. M equal to psi b by psi a into 1000 divided by Ma, right? So psi b is given as 0.1, psi a is 0.9, Ma I don't know because that only have to calculate, no, Ma, and molality, let us keep it as molality. Okay, so can I write this as 1000 divided by 9 Ma? So from here can I write Ma equals to okay, Ma only, Ma equals to 1000 divided by 9 M. This is one equation that I have got for Ma. Now, do you remember there is an equation for molarity and molality? So in terms of molarity, if I write the equation in terms of molarity, okay, if we go to the next page, I have to waste the page over here. Okay, I'm just shortening out it. Let me just decrease the size. No, Baba, what is the use of doing if one part is not coming inside only? What is the use? No need. Entire part did not come. Huh. Okay, now you see what I will do. Can I write molarity equal to md divided by 1 plus mmb by 1000? Remember the formula we discussed in the last class itself about this, right? Now I can use this formula or I can use the terms of molarity. Instead it will be better if I use in terms of molarity only, because molarity only we calculate. Already I won't calculate molarity anyways. Molarity terms of formula কি ছিল? 1000 m divided by 1000 d minus mmb. শেষ হয়ে গেছে। Okay, so m equals to 1000 m divided by this, right? Now can I cut the m and m? Cut means I am talking about this one and this one. Cancelled off. Why? Because in the question it is told m and m are equal. At 298 Kelvin, molarity is equal to molality. So can I cancel out the molarity and molarity? Or you want it to be remain? Cannot. We can just cut it off. Okay. Next. So it becomes 1000 d minus mmb equal to 1000, right? Okay, now let's solve the equation. D is given 2000, it will become 2000, D is 2, mmb equal to 1000. So it's basically mmB equal to 1000. So from here I can write mb equals to 1000 divided by m. Right? Now let us calculate it. So ma by mb, what is asked? What was your question? What was asked? Ratio molecular weight of solute to solvent. So I have to calculate mb by ma, solute to solvent, mb by ma. So 1000 divided by m into 9m divided by 1000. 1000 cancelled off. M and m will also get cancelled off because it is same. So answer is 9 by 1. So if the ratio is being an integer type question, so it will be oof, so it will be 9. Okay, this is the day advanced question. You can see the question is calculation based. Question is not difficult, but the question is calculation based, and the way you have to understand the question only, because again molarity equal to molarity, so we are definitely coming on to the relation between this. Okay. Acha. Next one. Acha. Chalo. This three I will do in the next class. Okay. It's becoming already. I think it is almost going to be time. It is almost 2 hours. So these three questions I will take up in the next class. Okay. These questions are basically based on that last part of the chapter where I was discussing about gram equivalent or law of equivalence. On that it is based. So I will discuss these three questions in the next class. Okay. If you want to try it out, you can try it out. I will discuss this in the next class. So I'm just writing over here homework. You want to try it, you can try. I will discuss this in the next class. Okay. Before ending today's class, I will just take up a small topic. I will just introduce that topic today and we will discuss in details in the next class. And now please be more alert because we are now beginning with the class 12 part. Okay. Today I am starting with the solubility of solids. Now we are going to start class 12's first topic, solubility of solids in liquids. Most importantly, we'll focus on the gas in liquid, but the first topic is solubility of solid in liquid. So solubility of solid in liquid. First of all, tell me what is solubility, huh? What is solubility? Solubility is basically how much solute you can dissolve in a solvent. How much solute you can dissolve in solvent. How much solvent? It is 100 gram solvent or it is 100 ml solvent. Okay, if it is 100 gram solvent or 100 ml solvent. Since it is a liquid, so it is going to be 100 ml solvent. So if I am talking about the definition of this, so it will be maximum amount of solution. Maximum amount of solute that can be dissolved in 100 ml of solution. Okay, since it is a liquid, so 100 ml of solution. So how much solute you can dissolve in 100 ml of solution, that is known as solubility. Definition simple. Okay, now next, solid plus solvent, liquid, sorry, solid plus liquid, solid plus liquid, right, where solid is a solute and liquid is a solvent. So this forms a solution, right? Now there are two parts of this. What are the two parts of this? When you go from solid, liquid, solution, that means you are mixing to solid and liquid to form a solution, then that is called dissolution. That is called dissolution. Dissolution. If you are going from solution to the solid and liquid, then you will call it as crystallization. Crystallization. You understand? From solution, if you are preparing the solid, and we will get it in the form of crystals because the liquid will be trapped with that. Okay, so then you will get it in the form of crystal. That is the process called crystallization. Is it clear? Now let us talk about few more terminologies. Few more terminologies. What are those? Saturated solution. What is saturated solution? If I talk about saturated solution, then it is maximum amount of solute is not. I'm just giving the concept. Definition is not required. Maximum of solute is not dissolved. That means at a given temperature you can dissolve more solute. It's basically maximum amount of solute. This maximum amount. Okay, at a given temp. Okay. Similarly, if I am going to talk about unsaturated solution, oh, sorry. This is an unsaturated solution, okay? This one was unsaturated, so saturated I will talk later on. Unsaturated. Okay. Now let's talk about saturated. So if the maximum amount of solute is dissolved at a particular temperature, then we will call it as a saturated solution. So maximum amount of solute dissolved at a given temp. Okay, so at a given temperature, if maximum amount of solute is dissolved in the solvent, then we will call it as a saturated solution. If at a given temperature maximum of solute is not dissolved in the solvent, then it is called an unsaturated solution. It means you can dissolve more in it, right? Okay. Next, another terminology is there, that is called supersaturated solution. Okay, that is called supersaturated solution. Supersaturated solution. Supersaturated solution means maximum amount of solute dissolved in solvent at higher temperature. That means after heating you have done that. Okay, not at normal temperature. Normally how much ever to unsaturated done. After saturated solution you are heating it and you are dissolving more, then that is supersaturated solution. Okay, always remember that this supersaturated solution is highly unstable. Okay, highly unstable because you have given extra na? So moment you shake a little bit, it will crystallize. On slight shaking, on slight shaking, it crystallizes. Okay, so even if you shake it a little bit, it will crystallize. So that you have to take care that you will not shake it around over there. Okay, next, factors. The last topic for today we will discuss is factors affecting the solubility. Factors affecting solubility of solid in liquid. Factors affecting solubility of solid in liquid. Number 1, nature of solute and solvent. Nature of solute and solvent. Nature of solute and now why? Why nature of solute and solvent is required? If the solute and the solvent both are polar, then it will dissolve easily. If both are non-polar, then it will dissolve easily. So like dissolves like and unlike dissolves unlike. unlike does not dissolve unlike. So that is the case, right? Like dissolves like. So if it is same type, it will dissolve easily. Okay. So just a brief idea. I'm just writing one word. You can just explain in it in a word, so it will not be asked. Like dissolves. Okay. Number two is temperature. Temperature. What happens? Understand this. You have to understand. Okay. Understand. First point. Dissolution endothermic. Dissolution. Let us assume that dissolution was endothermic. What is endothermic? Endothermic means you have to give heat. Endothermic means you have to give heat. So dissolution endothermic, that means when I am dissolving the solid in liquid, then I am giving heat. Very good. So if I am giving heat, then more heat I will give more heat. Then what will happen? More dissolve. Why? According to Le Chatelet's principle in class 11, Le Chatelet's principle says that reaction proceeds in a direction where it is endothermic. So if dissolution is endothermic, then solubility will increase. Clear? Why? Because more solution will be formed, solubility increases. So if dissolution is uh, endothermic, then what will happen? Dissolution endothermic, temperature increase, then solubility will also increase. Solubility increases. Okay. Example of this you have to remember is Na, NO3, NaOH, one curve we used to read in class 9 testing. Okay, did you understand this one? Next, if the dissolution is not endothermic, it is exothermic. That means dissolution is happening but heat is being released. So according to Le Chatelet's principle, the reaction will proceed in the endothermic side. So exothermic dissolution means reaction will proceed in the crystallization side. So if reaction is crystallization side, so if you keep on increasing the heat, will it take the heat? No. So what will happen? Solubility will decrease. So it will start to crystallize. So temperature increase, then your solubility will decrease. Right? So example, you have seen in that graph in class 9, calcium sulfate, Ca whole 2 SO4 whole 3. Then you have sodium carbonates, the lithium carbonate. These are all okay. And the last one and the exceptional guy. You always have an exception. You always have an exception. And who's the exception? Very, 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 very important. Exceptional guy. The exceptional guy is no regular pattern. No regular pattern. Suddenly increased, suddenly decreased. So what we are going to write under this irregular guy? No regular pattern. Okay, you have to remember the name. It's Glauber's salt. Glauber's salt. Okay, Glauber's salt is basically sodium sulfate decahydrate. Okay, remember this because it's an important exception. Why? What happens here? What happens here is, as you increase, first your solubility will increase, endo, then suddenly it will become exo. So it will be like this. Okay. So at this point you will get the maximum solubility around 32.4 degrees Celsius. So this part is endo, solubility increases. This part is exo, solubility decreases. This side the graph is solubility versus temperature. So you keep on increasing temperature, fine. Up to 32.4 degrees Celsius, fine. After 30.4 degrees Celsius, it keeps on decreasing. So no regular pattern for Glauber salt. Others explanation has been given to you. So we have started with solubility today. Tomorrow we will start with solubility of solids done today. Tomorrow liquids, gases in liquids. Okay, so tomorrow we are going to discuss solubility of gases in liquids. Achha, one more factor, let us write number 3, that is pressure. So remember that pressure does not have any effect over here. important, okay, does not have any effect on solubility, does not have any effect on solubility, on solubility. Solubility of what? Solubility of solids in gases, okay, solubility of solids in liquid. Remember, next time only pressure will be playing a very important role, that will be coming as Henry's law. So here in solids nothing, but next it will be very important, okay. So let us keep up till here for today. In the next lecture we will be discussing the solubility of gases in liquids, and that is going to be the very important part of this chapter, okay. So I hope you have enjoyed today's lecture and you have understood all the concepts that we have discussed today. So let's meet in the next lecture. Till then, keep studying, okay.